Welcome to Magnet and Data Storage. This is a project that shows you how data can be stored and digitized. In this experiment, we kept the word being stored constant, and we tried to figure out how far apart the magnets needed to be in order to not distort the information being stored. If the magnets are separated properly, then the maximum storing density will not be distorted. Distorted information leads to inaccuracy to figuring out what the word is. We created a table with the dimensions 12 by 24 inches. We then divided the paper into rectangles of 3.5 inches going across and 2.5 inches going down. With this table, we placed the magnet in the order they needed to be stored in. The goal of this experiment is to demonstrate the maximum recording density for storing digitized information using a grid of bar magnets. Information like words, music, pictures, or movies is digitized. The information is converted into a stream of numbers into a format that can be saved onto various permanent storage devices. The smaller units for digital information is called a bit. A bit can either be a 0 or a 1. By stringing together a series of bits, larger numbers can be created. Letters, numbers, and other symbols for printed text are digitized using a standard code called ASCII, American Standard Code for Information Interchange. Each character is assigned a unique code. A short piece of text is digitized using the ASCII representation of the text. Bar magnets represented in the individual bits of the digitized text. The orientation of the magnet determines whether it represents a 0 or a 1. For this experiment, you will need a large horseshoe magnet, a Sharpie, scissors, masking tape, 24 1-inch bar magnets, and a 12 by 24-inch chart. Okay. Before beginning this experiment, we have to label the magnets accordingly. To figure out whether it is north or south, you bring it close to the large horseshoe magnet. North and north will repel each other, so north and south will attract each other. So this side should be labeled south, and this side should be labeled north. Think of a 3-letter word or name or acronym to digitize. It can be anything you want. For this experiment, we chose the word gem. Make a table to translate your chosen word or phrase into the binary ASCII code. Tape several pieces of paper together lengthwise using your ruler to measure and draw 24 rectangles. Each rectangle should be 3.5 inches long, left to right, and 2.5 inches wide, top to bottom. Use individual bar magnets to represent each bit of the code word. Place one magnet in each rectangle on your paper. Arrange them accordingly to the code for your word or phrase from the ASCII code. After selecting and figuring out the binary code for your word, figure out how close the magnets can be before they attract each other. Find the highest recording density per square inch that you can achieve. Once you have found the highest recording density possible with your bar magnets, arrange the magnets on your paper again. We were concerned that our magnets would be too strong when we initially purchased them. We had to go through several trials before we found the correct dimensions of our rectangles to place the magnets so that they wouldn't attract or repel each other. We found that our magnets had to be 2.5 inches apart up and down and 3.5 inches away when side by side. We found that this project was harder than we thought. So our first letter is gem, and its binary code is 01001010. To start off, in order to get a 0, N has to be facing the left side. So we place N facing the left side. To get a 1, N has to be facing the right side. So we place N facing the right side. We then have to get another 0, so N has to be facing the left side. And we must make sure that they are not attracting each other. And after the letter E, our binary code is 01000101. Our next letter is M, and our binary code is 01001101. If the magnets are separated properly, then the maximum storing density will not be distorted.